I think we're live. We're live.
Okay. So,
Alright,
if everyone was
jump
right, A must have the number 8.
Yeah.
And then since there was only 12 cards, then no one else can have 8.
Yeah, that's if A is telling the truth, no?
Yeah. But, yeah.
Okay, it's telling you everyone's telling the truth?
Yeah, it says, in this case, it's true. In this case, it's true. Wait, if all these numbers are prime, none of the numbers of A is prime.
Alright, you guys think about it. I'm gonna toilet. I'll be back.
Can I just give it all to her? Sure. She's jolly on it. No, she's give it to her. Oh, she doesn't. She just wanted to. Yeah, Metal actually has different flavors. This actually has well, this is the OG. I don't know which one. What was a different? Pictures. Okay. Here's Nita. And the doll. Doll shoes. But not large. Here you go.
那个，你给我你的爸爸。哦，这个 headphone 没电。
No, Lucas is here. No. Composite. I think we've already talked about this. If a number is prime or if it's composite. No? Composite means it's the product of two different numbers. Two numbers times together.
Papa.
There's not one. Oh, Lucas is here.
Papa. What does that mean? Like when what were A card? One of A's cards are running 8 and 7 in this case. So that means one of A cards is 8. So we got one of how much cards is there? Oh yeah, 2 more.
Good.
Wait, you want the same cards? No, only 12 cards. I'm pretty sure it's 12 cards. So that means A doesn't have any prime. Well, the prime. It depends how much prime numbers are we want, but yeah. The more primes then.
They can't be. They're not composite. If it's prime. Prime is opposite of composite. It can only
Papa.
it can only be 1 times itself.
Papa. There can't be divisible. If B
And
says
also 1 is not prime. 1 is neither prime nor
if
composite.
B says all his numbers are prime, can A also have prime numbers? Wait, if 1 is not prime, then B doesn't have. Wait. So his numbers could like
Hey Lucas, can you hear me?
his numbers could be 3. 7. Actually, no. That's 3, 5, 7. 12, 9, 11. Gosh. 11. Those are the only possibilities. Those are the only cards we see. Papa,
Huh?
he says all his numbers are prime. Can A have prime number? Wait. The common prime divisor is basically like all his numbers are divisible by a prime number. Like, is it a prime number if it's divisible by? D doesn't really matter. I don't think.
Hmm.
Baba.
Hmm.
But if B says all his numbers are prime, can A have all his numbers prime? Wait, I'm prime numbers.
Well, A is got 8. Yeah.
No, can it be half it?
Yeah.
Oh, that's a new trick. We just have to know what cards B, C, and wait, B and C have.
Mm.
But actually no. B knows what cards B, C, and B, C, D. Why? We need to know what A is. Um, wait, common prime is 5 and the divisible by prime number. What? The what? I don't understand something. So does that mean A is right? Baba. Dad, add. My concern. And wait, is it that everyone is right? Is A right? I want you to see. If everyone's right, then A and C. Is A right? Is everyone's right? Yes. Come in. Hi, Alex.
If he's sitting there, you get that out of the way. Oh, try a t-shirt on. Alright, what size are you?
16.
16. See if you fit in this. Does this fit? Just put it over the top. If it doesn't fit, give it back. Well, let's give it back anyway. Alright.
It's
Is it small? Small, huh?
it's small because
Alright, try this. I think this is even small.
No, the biggest size was 14.
Medium, try medium. Yeah, good.
Wait, what Sometimes I do that.
Extra large.
Oh, they have XL, but they don't have the XXL.
Extra large.
Yeah, extra large.
You know what this is size? Do they have XL? Yeah, they have XL. I
Yeah,
think
Yeah.
it's XL.
Is it better than the other one?
Yeah, put it on heavy.
We are in I think it changed.
It's okay. Just
Yours is already 30.
merchandise.
What do you think?
Pretty cool.
Merchandise.
I know what it is. Merchandise.
Alright, do the pearls.
I can flex on your puppy. And you have to pay any money.
You know there's a tournament this Saturday, right?
Cool.
It must have.
Yeah. That's the paper I wrote.
This one. So. Square number.
I think I might know what that means.
I already told you what composite means.
I don't know how to explain it.
Just like
Well, in this context, composite means like not prime. It's a you can get two different numbers and times it to get that number, and one of those numbers cannot be one. So like 6 is composite because 6 is 2 times 3.
Wait, so is it like the result of the
opposite of prime.
yeah, basically?
One is
I
neither.
understand. Composite is just a number times itself.
No. That's square number. Composite is like not prime number, but not one.
4 times.
Not a prime number, but not one.
That's basically just anything.
Yeah, except one.
Wait.
There's like one. What do you call one?
One's neither.
Is it comp prime?
It's neither.
So which one is it? What classification is it? Is it the mother of all numbers?
It's probably like
It's not.
for me.
Because like a prime number must have at least two factors, which is one and itself. Like one only has one factor, because it's one and one. Like so.
So since it's not
It's neither.
Yeah.
Oh, shit.
The really prime numbers.
Prime numbers they're not composite.
They cannot.
They
can
can't
only
be factored.
They
So
can
5
only
is
be
prime.
factored by
5 is not
one
anything.
or itself.
Oh yeah. Wait, the only cards B could have is 5, 7, or 11.
What about two?
Twos. Those are the only cards.
No, I can't see how.
Wait, I think you can only like find out what cards kind of in C.
Yeah, I found out C. I think.
You probably even see when 6 cards is 6 cards go in.
No, C must be a multiple of 2, 3, 2 or 3. Must be multiples of 2 or 3. Because 5 is too big.
Like prime divisor is that?
Like, it can be divisible by something prime.
These are like so like anything not like anything
Like, the divisor doesn't have to be one of those 12 numbers, but like, it sort of does, but like, it does, but it doesn't.
it's so big. Yeah. Six.
Maybe there are more possibilities to feel on the third.
Wait, if like a composite is even, it has to have a
Because there are 11 possibilities to see.
11 possibilities for C.
Because that's the amount of possibilities. The only numbers that are composite and don't have a common prime divisor was 3, then only was 6, 9, and 12. If the divisor was 2, you could have 4, 6, 8, 4, 6, 10, 4, 6, 12, and yeah. Yeah.
Well, you can have 4, 6, 8, 9, 12. Those are the then then D we can't know yet.
Yeah, because
It
all it says is I know all the cards.
I mean like that's not useful unless he's gonna tell us what.
Unless we know what the other cards are.
Like because he knows all the cards. We're trying to figure out like useless.
What if we ask, if we could, then we would just ask this. Oh, never mind. Maybe we're actually.
Oh wait, C can't have the card 8.
Yeah, because also.
It's
Because A has
A
numbers.
has 8. A has 8, so it can only be
So
5.
I'm just trying to eliminate the ones that. Eliminate how many we can.
And D, we're just gonna say like the one for D. We can just say like the ones it can't be like 8.
Yeah.
Can't be 8 certainly.
Yeah. Okay. So,
I guess D is giving us scripts that can find them out of.
Six. So there are 5 possibilities to see.
5.
Yeah, 5 possibilities.
Yeah, 5 cards. It could be.
Yeah, 5 possibilities.
There it is. 5.
Yeah. They've got 6, 9, 12, 4, 6, 10, 4, 6, 12, 4, 4, 8, 10, 24, 10, 12, 6, 10, 12, and
But you already did 6 times.
6 and 4. Sure. I didn't. I did 6, 9, 12.
Oh.
6 and 4. And there's 10. Oh no, it's not enough. 6, 9, 12, 4, 6, 10.
What about 12, 10?
9, 12, 10. 9 is divisible by 2. 3, 6, 9, 12 are divisible by 3, but 9, 10, 12. I don't think they have a
Wait,
common
they have to
factor.
be divisible.
They have to be divisible by the same number.
Like if you add them up, they have to be.
No,
Like,
like
they have to be divisible. Each number has to be divisible.
by a specific number.
Oh.
Yeah.
Or they all have a common.
Yeah.
So to find out what D is, you basically have to eliminate what D can't. Like,
Yeah.
A still has 2 more cards. So like, even if we, for example, 6 and 4 won't even be or C.
If we knew what D had, then we'd know what A has, because D says since if D says he knows all his cards and he knows all the other cards of each other wizard, then that means if we know the cards of D, then we know the cards of all of them. Yeah. Which includes A. So if you find D, then you can find A. Hard part is trying to find it.
Because if we can find all 3, because if we find B, C, and then with that means we can find D, and once
Not necessarily.
find it. But like, once we do find D, we basically found all the others, so then just 2 cards left is A.
Well, you know what? Part of the answer is 8. Oh,
Yeah. Yeah, that's the big.
Unless it's supposed to be there. Oh, it might be there just to eliminate those 6 possibilities in C. Might be there for a reason.
Yeah, that's the hard. At least
I think it's there on purpose. Like, in a way. Well, I was just thinking, if we find out B and C, then there'll be 5 cards remaining. So we don't know which ones are going to be in D, A. We don't know which ones are going to be in D, which are going to be A. So I think we have to figure out the like B or C and then figure out A or B.
But then how do we like continue from
Okay. Probably not trial and error.
Just take
Yeah. I don't really know. He has 10 possibilities. Yeah. He has 10 possibilities. Yeah. He has 10 possibilities. There's no other way he could figure it out unless he said that. So we need to work it out. How deep do just do that. So, yeah. First of all, like these are 10 possibilities and 5 numbers. But he might have two of those numbers, therefore telling him what he would do. Tim would C and A.
See, all we know about T is on E8 mix B or C. Wait, but like,
I just get a feeling that D or A should be 1. Oh yeah, they have to be, because because 1 is neither prime or complex. There must be A or D.
yeah.
So that means that 1.
Because it could be either one, but we don't know which one.
Yeah.
Because he doesn't give an option what he has.
Yeah, just because he knows what the cards.
And then A only just gives what one of his cards off, which is nothing related to the other two cards.
Yeah.
So then, why don't we find out which one goes to first?
The only thing we find out with A is that part of the answer is H, and that
I feel like
C has
we
5
have to do B and
instead
C
of 1.
first. Nope. I feel like we have to C.
Yeah. I feel like we have to do B or C and then A or D.
Well, I mean, you didn't really work it out like
So let's try and work out BOC first.
Well, we can't really work it out like it was he has his own cards and you can see his own cards. You can't
Yeah.
see it.
Can't see when we do this.
Lucas, how's it going? How are you guys going?
We found that A and B, either A or D,
Has one.
have the card 1.
Because one is neither prime or nor composite.
And the cards 2, 3, 7.
Yeah.
The cards C could have
C
4,
has
6.
5 possibilities, and
Wait.
has 10
And the
possibilities.
cards C could have is 4, 6, 9, 12. I figured out something. So, you know how says what was the cards if everyone was right. He says he knows all the cards of each wizard, but over here it says and will see only his own cards.
Then what?
So how?
How does what?
Are you saying the question's too hard for you? No, how does D know all the cards they say only can
Because
see
of the
them?
information they say out loud, he knows all the cards because he knows his own cards as well. Like, let's just say, we had 5, 7,
okay.
and 11,
Oh, so Lucas, you haven't figured out the first problem
and
yet?
D
Yeah.
has 2 and 3. Then he knows that B has 5, 7, and 11 because he has to have prime numbers, and he has 2 of the prime numbers out of 5, therefore making him know B's numbers. And for C, he can work it out because, like, what if he had, let me see. What if he had, 4 and 6, for example? Then he must know that, wait, what if he had, 4 and 6? That would make,
Wait, I think D
yeah,
has
that
to
rules out
wait,
one possibility, which
wait,
is,
I think D has
what?
to be 1.
D has to be 1.
Because on B it has 2, 3, 5, 7, 11, right?
Yeah.
That's 5 numbers. C has 4, 6, 9, 10, 12. That's 5 numbers.
Yeah.
So then you have to give 2 of the numbers to A. So that's leaving the 8 numbers. And they take 3 from them.
What do you mean? So, like,
And then they take 3 for themselves. And then D only gets 2 cards, not 3.
the D has 3 cards. Why would D not have?
Yeah, but it's like excluding 1, like excluding 1, B and C have these possibilities. 10
Yeah.
numbers
Yeah.
altogether.
Yeah.
And then 3 for each of themselves. So that's -6. So that's 4.
Yeah.
2 is given to A. And then D has 2 cards. Excluding 1. So if we add 1.
Wait, 11 minus 6 is 5.
No,
not 4.
10.
Wait, why 10?
Because like each of them have 5 cards. B and C.
Wait, so if A has 8 and D has 1, B and C have 3 each, therefore making 4. So 2 for each of A and D. So what do you mean?
So like D wouldn't have enough cards if 1 wasn't there.
Why do you say that?
If he doesn't have because if
Yeah, but exclude minus 6, then there's still 4 numbers left, right? What if you had 3 to D and 1 to A? Wait, that means there are 5 prime numbers. There are 3 that B uses, so the other 2 must go to A and D. So therefore, there must be at least one of A or D must have a prime number. A or D must have.
What do you mean by that?
So like B takes 3 prime numbers, right? So therefore, there are 2 extra prime numbers, and since C has all composite, that means A or D must have at least one. A or D must have at least one prime number.
That was the same opposite answer.
Yeah.
But then that's not necessarily true.
That's not
A could have
Wait,
all of those all of the
A could all, which is why A has at least one composite number.
But if A has all the composites, then D has one. If
Yeah. Look. Wait,
Or
not,
they could
wait,
take-
not necessarily.
or they could take
Because like if A takes both of the composite numbers,
yeah, it could take
one, and then D
No,
D takes all of the other spare numbers.
one isn't
Yeah. So
and A's already got 8. But like A could also take
it doesn't say any like rule about the
if there was that
usually research.
Hello? Aiden, can you hear me?
Yeah.
Yeah, so we're just trying the problem. Can you see the problem on the board with the wizards?
Yeah.
Yeah. Lucas said he's found the answer. Have you guys found the answer?
No.
What have you got so far?
So far we've got A has 8 and it says in there. 5 possibilities for C.
Let me write this down. So
And
you're saying
so far we have 5 possibilities for C.
It's 5, and also 5 cards, which is 4, 6, 9, 10, 12. Yeah.
4, 6.
9, 10, 12.
For C.
Those are the cards.
But like, those are the cards that would work. But like, they don't necessarily work with each other.
Yeah.
6, 9, and 12 are one, but like, you can't do 6, 9, and 10 together.
Yeah, so you can either do 6, 9, and 12, or like 3 of the 4 even numbers, yeah?
And for B, the cards are 2, 3, 5, 7, 11.
For B,
Yeah,
they're
the
2, 3,
cards
5,
for B.
7, 11.
2, 3, 5, 7, 11.
3,
3, 5, 7, 11.
Yeah.
And A, neither A or D would have. Just don't know which one. A or D would have. Right now we don't know. It would be A or D.
A or D has 1.
Yeah, we do. Because one isn't prime. So it must
So
be
we
A.
know that A or D.
So are these all the composite numbers?
They're all the ones that were.
Yeah, those
Okay, and then you're saying you know A has 8 as well, yeah?
Yeah.
And then the only number left is 1, right?
Yeah.
Oh, there's 2 numbers left.
Yeah, it's one. It could be one or some or 2 of them.
There's 12 numbers all up, right? So there's only 1.
So A must have 2 other. A or D must have at least 1 prime.
1 prime.
Hello?
A or D.
Yes, Lucas? Hello? Can you hear me?
My microphone wasn't working for a bit.
Oh, okay, I can hear you now. Wait, so just give a sec. So we have 8.
We use 3 prime ones, leaving 2 prime ones for A and D.
Mm-hmm.
Same for C. We will use 3 composite ones and leave 2 for A.
So what are you saying? So there's there's 5 primes here, so 2 of them have to be with A or D, right?
Yeah. Or they could have one each.
Or they can have, yeah, that's what I meant. Yeah, so actually, D would know where all the cards are.
So if we knew all the cards of D, then we would know the answer.
Yeah. So if D had like 2 of these primes, for example. So what if D had 2 of these primes? Would he
Then
know the answer?
if he had 2 of those primes, then he would know what B had.
Yeah, he would know what A has. Would he know what A has, or would he know what C has?
But he'd probably try to work out A last because he'd probably try to work out A last because he only knows that A has page.
Yeah, no, I'm saying I think he can't figure it out, right? Because if D had both primes, right?
Yeah, then he can't figure out C.
He can't figure out C, you know? So he has to have something to figure out C.
What if he had a prime and
Like, what if he had 2 composite? If he had 2 composite, then
what if he had prime divisor?
I know.
What does divisor mean?
I said definition questions at the start, right?
Wait,
You ask that now,
if he had
speak
6
quiet.
and 9, then he would know what C had. But he wouldn't know what B had.
What if he had a prime number and
So therefore D must have. Wait, what if D had one prime number and 2 composite? But he still wouldn't be able to work out B. Still. So what if D had 1 prime, 1 composite, and the number 1?
Hmm.
Wait. Oh, so D must have 2 prime and 1 composite. Because if he got 6, then that would remove 9, makes 4, 10, and 12 for C, and for B he would have 2 of them, therefore leaving there with 2 more, therefore knowing which numbers B has, and then all the spare numbers which are A.
So you're saying if he has 9, so if he has 9, then C has to have.
Now, if he had 6, 2, and 3, for example, then he'd know all the cards. Because if he took 6, then that would remove 9, because 9 only works with 6, 9, and 12. So if he took 6, that would remove 9. So C would have 4, 10, and 12. If he had 2 and 3, then B would have 5, 7, 11. Then A would have 9, 8, and uh,
like in one be
so A has 8, 9, and 1. B has 2, 3, and 6. C has 4, 10, and 12. And B has 5, 7. But we don't know if which prime numbers that D has. D has. But we know that D has 6, otherwise we wouldn't be able to do it. Because if we had 6 and okay. So D must have 6 or 12. Because 6 or 12 would be 6 and take away 9, 6 and 12 still can both be divided by 2. So D must have 6 or 12.
Because it must have 6 or 12.
Yeah.
Why is that?
Because otherwise you wouldn't be able to work out C. Because if you didn't have 6 or 12, then you'd have to have say 9 and 10. 9 and 10. Now, if you didn't know that, then you would have to have two opposite numbers, and therefore the other number must be primed. So if it's 1, then you won't know what B is. If one of them is primed, you still won't know what B is because there's still two possibilities. So
Yeah.
therefore D must be 6 or 12.
Right, so to know the primes that go with A, yeah?
Yeah.
Like, should D... Oh, D actually knows what primes go with A, right?
Yeah.
Just from looking at his own.
But we know that A has 1 prime.
So actually, D doesn't need to have any primes to know... Like, it'll know A no matter what. Like, the primes, from the point of view of the primes, you know? But, to know what's in C, it really needs to have something, you know?
So we know it must have 6 or 12.
Okay, so why does it have to have 6 or 12? Lucas, hello. You want to add to this discussion? So why does it have to have 6 or 12? Is that what you concluded as well? Lucas, can you hear me?
So there's one way that it would occur to you. But aren't there multiple things that could fit with the criteria?
Okay, so let's suppose D has you say like 6, yeah? So let's suppose D has 6.
Yeah. If D has 6, then
So if D has 6,
C
okay,
can't have 6 or 9.
so there's not enough 3s, yeah? So
Yeah.
C has to have 4,
And then
10, and 12, yeah?
Yeah.
Okay.
And if he has 2 or 3, for example, then B has 5, 7, 11. Therefore, A has 9, 1, and 8.
Okay, so 9 has to go with A no matter what, yeah?
Yeah.
Okay. So now the question is, does 1 go with 6? Or does 1 go with A, yeah?
1 goes with
Why?
um, if D has 6, then A has 9. Also making, if D had 2 of B's numbers as well, then he would know what B's numbers are, he would know what C's numbers are, and he would know what A's numbers are. So which on one hand,
Wait, can you say it again? So if you're saying if D has 1, yeah?
no, if D has 6,
Yeah.
then A has 9.
Yeah.
No.
And we know
Um,
C, yeah?
And if he has 2 of B's numbers, then he knows what the remaining numbers there are, so he knows what numbers B has.
Uh-huh.
If he has 2 of B's numbers.
Okay, but if he only has 1 of B's numbers, he doesn't know. That's what
Yeah.
you're saying, right? You don't know which one A
So,
has.
so he must have 2 prime and 1 opposite. Opposite would be 6 or 12.
So it has 2, 3. And then
Yeah.
it has 1, yeah?
Yeah.
Okay, so can you see that's basically very close to solving the problem, yeah?
Aren't there multiple possibilities then?
There are multiple possibilities, but can you see that the conclusion is going to be the same, right? Because it's suggested by the question as well, right? So your claim now, you got a statement you're trying to prove now, yeah? So you're trying to prove that A has the cards 8, 9, and 1 no matter what,
Yeah.
right? Sure.
So we know which cards A, but we don't know.
Huh?
But we don't necessarily know. Wait.
But that's what we're claiming, you understand?
Wait. Oh, wait. Maybe that is true.
I mean, it has to be true for the question to work, right?
Yeah, but. Cool.
So to prove something like this, okay, so it's not over once you get 8, 9, and 1. That's not the answer, okay? Like, you need to prove. The proof is worth all the points. Understand?
Yeah.
So, like, we just took the case that D had 6, yeah?
Yeah.
So we could actually try some other cases too, because there's only so many cases, right?
Yeah. If you had 12,
So if D had 12, yeah?
then C would have 6, not changing.
C would have
6,
4, 6, and 10, yeah?
yeah. Instead of 4, 4, 10, 4. If you took, and we know that for B, whatever number he takes, he still knows what B has. And that
Huh?
doesn't change. Whatever numbers he takes, whatever prime numbers he takes, that doesn't change numbers of what A has.
Whatever numbers.
Whatever prime number B has, it doesn't change what number A has. It doesn't change any number A has.
Hmm? Yeah, so A will still have 9, right? Yeah?
It has to have.
Yeah. Yeah, so as long as D has an even number, A will get 9, right?
Yeah.
Oh wait, hold on. As long as A has a number that has divisible by 3, then A will get 9, right? And if A gets 9, then it probably also has to get 1 too, right? Yeah, because the B can't have all. You have to know what B has, you know? Okay, so then maybe it's good to try to consider a case where A. So actually, can you probably just prove that A always gets 1 no matter what, right?
Yeah.
Because D has to have at least 2 primes for
What B is.
to know what B has, right?
Yeah, and 1 to know what C
So maybe
is.
that's a better place to start because it fixes things more rigidly. So it has to have 2 primes, and then A has to have just no primes and a 1, yeah, and an 8, yeah. So then it's just a question whether A has a 9 or not, yeah. Okay. But if it doesn't have a 9, then C has to have a 9, right?
Yeah.
And
But C can only have a 9 if
oh wait, actually,
there's 6 and 12 others available.
oh no, so if it doesn't have a 9, D might have a 9 or C might have a 9, yeah.
Yeah.
So if D has a 9,
D has 9, you would have to swap it with composite because otherwise you wouldn't know what B is. So,
wait, so if D has a 9, right?
yeah.
That doesn't work because you don't know what C has, right?
Yeah.
Unless you had a 9 and something else, but then you have to have 2 primes, yeah?
Yeah.
Okay, so that doesn't work. So D can't have the 9, so then C has to have the 9, right? If C has the 9, it has to be 6, 9, and 12, yeah?
Yeah.
Which means that D has to have a 4 or a 10, yeah?
So then D can't.
Yeah, so if D has a 4,
But still, if we have a 4, then
10
we
goes
don't
with
know
A,
if C has 6, 9, and 12, or 6,
10 and 12.
yeah, 6, 7.
So you can't have a 4. And the same reason for 10, right?
Yeah.
Okay, so that proves it. You understand? So this is kind of like the geometry problem, right? Like you show you get one case to tell you what the answer is, right? And then then you have a target to show what the solution is for all the cases. You know?
Does the question work if right has changed to wrong? Like if everybody was wrong?
Probably not. um,
I think it does.
what? You can't be pretty sure. You need more time to be pretty sure.
It doesn't work.
I don't think it's like good to conclude one way or the other unless you really know. But
Yeah.
okay, well that was a good first problem, yeah? That was an interesting problem. Alright, let's put the next one up. Yeah, Lucas, Tournament of Towns is this weekend, yeah?
Okay.
Yeah, so hopefully your mom's got the email.
She does.
Yeah. Good. Alright, let's put the next one up. Oh, oops, that's not good. Yeah. Put this number. Something.
So I found out how it works, but how do you explain it?
Hmm.
It works like 8 is not 8 is confident. Therefore, you can make 2 times 4, and 2021 is like 20, like 40 times 40 is 2000, 3 times 7 is 21, so therefore making 43 and 47. So we add an 8 in the middle, add a 2, a 4 in the middle of 40, 43 and 47, which then makes it, for 20,800, 423 times 447.
Are you sure?
Pretty cool.
Is what you're saying making sense? Is the 8 between is not timesing the 20 and the 21. It's the number 20,821.
Wait, is the dot mean time?
Yeah. Really? Yeah. That makes sense. I think it makes sense. This one,
Any ideas? Okay, so the problem I have with you guys, okay, is it's a very simple thing to be doing, but you're not really doing anything, okay? That's my problem. So, there's nothing new, okay? So, look what the question is asking you. It says, if you have 20, 21, yeah? So 2, 20, 21, yeah?
Yeah.
That's composite, yeah?
Yeah.
Okay, in particular, it's 43 times 47, okay?
Yeah.
And then it's saying that if you put an 8 here, okay? Yes?
Yeah.
It's still composite, right? Did you check it was composite? None of you checked it, right? Because this is not something that's easy to check by just staring at it, yeah? Because you think you don't have to check it because you want to show all of them are composite, which is lots and lots of 8s, but why do you forget about a single 8? Why is this composite? You don't know after all this time, right? So that is your failure, do you understand? Do you understand? Because you failed to adapt to what I've been trying to tell you, okay? It's got nothing to do with the problem, but I just say, okay, when you have a problem, try the thing, yeah? And then when you see the problem, you don't try the thing, okay? So how can you learn? Maybe you should learn from someone else, right? What I'm telling you, you're not doing, okay? You have to try it, okay? So if you try 28, okay? If it's not prime, let's try to figure out what could be a prime divisor of this, yeah?
It's not divisible by 3, 2, or not divisible by 3 or 2.
No, it's
800 is
Yeah, but that's like it's a dumb realization because it's so late into the problem. Do you understand? And you never even tried to see what factors are of this. Do you understand? Like, is this number divisible by 3? Is it divisible by 5?
No.
Is it divisible by 7?
Uh,
It's not. Is it divisible by 11? Make sure it's not divisible by 11? Or if you divide by 11, this becomes 9, 8, 2. Well, you can just make it 1, 0 if you want, because 11 is just that. Yeah? And then you can get 88 out of this. So you can do like 1, 1, 0. Okay, and you get 99 out of this. Then you get 2 zeros. So it's not divisible by 11, yeah?
yeah.
Is it about 13?
No.
Hmm? How do you know? So this is 7, 8, 2, 1, and then 13 times like it's like 65 and 78, yeah. So then that's gone, and then it doesn't go to 21. Okay. All right. What about 17? 17. 17 becomes 3, 8, 2, 1, right? And then it's 4, 2, 1, right? Yeah, and then 17, it becomes 81, right?
Yeah.
And then 17 doesn't go into 81, right? Okay. Does that make sense what you're doing? You're trying to test if it's composite or not, yeah? It's a very obvious thing to do, okay? It sure the hell beats staring at it doing nothing, yeah? So, what's the next number? Like 19? What'd you say?
19.
Yeah, 19. So you have 1, 8, 2, 1, right? Yeah. Okay, well we know 1900 is divisible by 9, so then it's just the 79 left over, yeah?
Yeah.
Okay, and then that's not divisible by 19, yeah?
Yeah.
Okay. Alright. I'm gonna try 23, yeah? Okay, so 23,000 is divisible by 23, so you can try like 2, 2, 2, 1, right? Okay, but then like... Oh, oops, not 2, 2, 2, 1. 2, 1, 7, 9, yeah? 2, 1, 7, 9. Is that divisible by 723? So you can try 121, right?
Yeah.
So yeah, 5 would be 15. Yeah, it's not. Okay, then you're gonna go all the way to 29, right?
Yeah.
29. So divide this by 29. You get like 8179, yeah? So 29,000 is by 29. So subtract this from 29,000, it's 8179, yeah?
Yeah.
8179.
And then,
Try to divide by 29, yeah?
yeah.
Okay, 29 what times 2 is what, 58?
Yeah.
So 58, that'll be 23. 2379, yeah?
Yeah.
Or like, we can even do 2350, for example, no? It's 29. Okay. And then, so 2900 minus 2350 is 550, yeah?
Yeah.
550. And what's a close number to 550? So 290, 580, yeah? And then it's 30 left over. So it's not divisible by 29 either, yeah? Okay, so I guess we're kind of running out of time. So I might keep going, but I won't be able to do more 8s, but I'll kind of explain what might happen, okay? So, what's the next number? 31? 31, yeah? You following? You guys should be able to do it yourself as well. So 31 times, like, let's say 6, yeah? Is 186, yeah? So if you subtract 186 from 208, you get 22, yeah? So it's again, it's 2, 186. Okay, and then 222 is reduced by 31. Well, you can subtract 186 again. So you get 36. And then you subtract 31 from that, you get 51. So it's not reduced by 31, okay? Alright, so the question is, what about 30? So it's not 33, 35. So 33. So 37 is next, yeah? $37 is reduced by 37. So 37 times 2 is 74, yeah? So times 4 is 148, yeah? So you can minus like 148 from this and you get 6021, yeah? Shelley watching. Okay, and then 60 minus 37 is just 23, yeah? That's 2, 3, 2, 1. And for example, 74 times 3. 74 times 3 is 222, yeah? So if you minus that from this, you just get 10. 101. Okay, and is 101 divisible by 37? It's not, right? Okay, so then 39, 41. Let's try 41, okay? Divide this by 41. Well, 41 times 5 is 205, yeah? So then you can get 321 from this by subtracting 205, 100. And then 205 away from this is 116, right? And 41, 41 doesn't go into this, right?
Yeah.
Okay. So then try 43. So 43 times 5.
Is one of the numbers at 2021.
Yeah. Yeah, so 43 goes into 2021, right? So we can actually subtract 2021 from this, and we get 611, right? Okay, the 611 is that divided by 43. Well, we can subtract 43 from this, and you get 18, yeah? And 43, if you times it by 4, yeah? It's like 172, right? So it doesn't go into this. Okay, so now we try 47, yeah? Okay, so you're stumbling across something interesting. 47 is one of these numbers here, right?
Yeah.
So you can subtract 221 from that, yeah? So then you get 611 again, yeah? And 611 is divided by 47. Okay, well you do 14 and 1, right? So you subtract 47 from 61 and you get 14 and 1. Okay, so what's 47 times 3?
That's 41.
Yeah. So that means this is composite, right? It's divisible by 47. Okay. And so if you keep
I feel like it's also divisible by 51.
51,
Yeah,
no.
it's like
No, it's not divisible by 51. Because 51 is divisible by 3. So if it was divisible by 51, it would be divisible by 3. Okay, but the thing is, so the point of that is now you know it's composite, right?
Yeah.
But one of the reasons it's composite is that it's divisible by 47, right?
Yeah.
So there's actually a chance that it's always divisible by 47, you understand?
Yeah.
And that's the reason it's composite, you see? Okay, and this is why like you got to test things. You can't just think about nothing, okay? Because this actually allows you to understand the question. Because I think realizing that 2021 has a 47 and subtracting it from this number actually really makes a big difference in the calculation, right?
Yeah.
So I guess this is for homework now because we can't do this for much longer. But you should see what happens if it's with 8 and then see if you can prove it's what happens for all of it, yeah? So this is your homework. Do it for 2 8s. Yeah? And it's a fun little exercise anyway, right? It certainly beats doing nothing. Okay. Okay. So you don't even have to like sometimes if you have a strong hunch, you don't have to start from 3 again, right? You can actually just start at 47, you know? Okay, but let's skip that for now.
But 208021 is divisible by 3.
Oh, what? Lucas has Discord now? Hold on, I'm gonna add Lucas to Discord.
Nice. That is divisible by 4. 208,821 is divisible by 3.
This one
Yeah.
is divisible by 3.
Yeah.
Oh, it is, yeah. But it could also be divisible by 47, you know what I'm saying?
Yeah.
Like, the other one's not divisible by 3, so you can't prove that they're all divisible by 3 for them, right?
Next one is divisible. So dramatic. One with 5 there. 5 eggs.
Okay, I'm gonna copy this link here. Yes, sir.
That's your one. Was that your one?
Yeah.
If you get more than 500 people in your Discord, you start getting money.
Really?
Yeah.
Are you sure?
Like 500 people in your server. So like more important.
No way.
If
How?
you get money off it,
Wait, how does your mom know anyway?
Alt accounts.
I think that's what my sister said anyway.
But how?
I don't know.
Like, who pays you? Discord.
Discord, yeah.
Really?
It's just like YouTube, like if you get enough
Making
subscribers.
millions, just getting 500 accounts.
But 500 people in the server, that's quite a lot for one server.
Yeah, but you're gonna buy a lot of devices.
But what if you buy 500 devices and make 500? Wait, what if you buy one device, make 500 Discord accounts, add them to your one server,
Oh yeah.
I've been kicking people out the server.
Oh, you should stay with me.
Alright, last problem, okay? Last problem, Michelle. Get in while it's fresh.
Also, I've got my,
If you catch late, you'll miss the problem. Find the largest positive integer n such that each prime with p between 2 and n, the difference n minus p is also prime. Have we done this one already? Is this the same as prep? Oh my gosh, hold on a sec.
I don't know.
It seems like we've done it before. It looks like I have.
Alright, let me have a look. Is this actually just prep n1 or n2 or something?
I have.
I'm pretty sure that's why Discord's 12 plus something. 12 or 16 plus.
Why?
Because you can start earning money off it. You get enough.
Yeah,
People
but
myself.
once you're 13, it's like you still don't get a job yet.
Yeah, true.
Just stop. 16.
Yeah,
Alright, focus on the problem. You always talk about dumb things. Focus on the problem.
like P is prime. Okay.
It's not on the prep. Maybe it looks familiar. I mean, we might have gone through it before. Have you guys done this question before?
It looks like
No.
it looks like we've done it before. It looks
Can't
like.
N just be
And-
biggest, like the biggest ever positive, the biggest ever positive prime number plus 3, and then
Plus 3.
P would be.
I've never
prime
done
is
this from some or else.
yeah, like so like the biggest possible the biggest possible prime number plus 3, and then is n, and then p would be the biggest prime number. So then n minus p equals 3. And since numbers can get like really big.
Yeah, so look. Michael, what are you doing? So you gotta try numbers, yeah? You don't even understand the problem, okay? So take the number, like, n is bigger than 2, yeah?
Yeah.
So take, like, 3, yeah?
Yeah.
Okay, so there's no primes between 2 and 3, right?
And it has to be at least, n must be at least 4, because 3 has to be more than p, and p is more than 2.
Yeah. So n, then take n as 4, yeah?
Yeah.
And 4 minus 3 is not prime, yeah?
Yeah.
Okay. Like n equals 5. Like, it's not a very difficult thing, right? Like, try the numbers.
just be any number plus a prime number.
Oh yeah, and it has to be at least.
N could just be a prime number, the prime number plus another prime number, and then the prime number be one of the prime numbers that N is included with. Like N is like if N could be double a prime number, and then P could be a prime number, that same prime number that was doubled. Doesn't that make sense?
So if n is twice a prime number, yeah?
Yeah. If N is double P,
Yeah.
then that will always work.
Yeah, but it has to work for all the primes between 2 and n. Like, if n was always triple p, that would be more conclusive, right? Because then it wouldn't work, yeah?
But if it was double P, then it would work.
No, it would only partly work, yeah?
Why would it
Whereas if it was triple p, it would fully not work, right?
Why would it only partly work?
Because it's for each prime.
Oh,
So you have one prime, yeah?
yeah.
But you don't have the others. Okay? Whereas if you had 3p, you minus p is 2p, it's not prime, right?
Yeah.
Which, because one of them fails, it means it doesn't work for each prime, right?
Yeah. I don't know. Um,
Have you tried some numbers?
Yeah.
What number are you up to? Hmm?
Not much to be honest.
Uh, Aiden, Lucas, have you got anything?
I'm just trying numbers.
Alright, what are you up to? Can we try one together or something? Does any number... We try a number like what, like 8? You wanna try 8? Yeah? We have 3, 3 and 5 and 7, yeah? But if you minus 8 minus 5, 8 minus 3, 8 minus 7, so 8 minus 7 is not prime, yeah? Okay. So we haven't found one that works yet. But we try like...
5 is 21.
Well, we try like 9, yeah? So 9 minus 3 is 6, yeah? 9 minus 5 is 4. 9 minus 7 is 2, yeah? Okay, so can you actually see that when you do 9, it's probably gonna be even, yeah?
Yeah.
So it's very hard for it to be prime, you know what I'm saying?
Yeah.
So you probably should try even numbers, yeah?
Yeah.
Okay, so if you do 10, okay. So 10 minus 3 is 7, that's good. 10 minus 5 is 5, that's good. 10 minus 7 is 3, that's good. Yeah?
Yeah.
And so actually 10 works. Yeah?
So we need to find the largest one.
So the answer has to be 10 or more, right?
Yeah.
Okay.
What if it's just what if it's just multiples of 10?
Okay, you want to try 20? Okay, so if you look at 20, I think the problem with something like 20, okay, is that 20 is 4 times 5, yeah? 4 times 5, yeah? What's wrong with 4 times 5? Well, what's wrong with 4 times 5 is when you subtract 5, it's going to be 3 times 5, yeah? So actually, that also tells you that it can't be like a multiple, like, okay, so I'm going to say something, you tell me if it's right or not, okay?
It can't be a multiple of a prime.
So it can't be a multiple of a prime, is that right?
Unless it's double.
Yeah, so it's not completely right. It could be double, because 2 times 10, right?
Yeah.
So the multiple can decrease by 1 to become a prime, right? So it can be twice a prime, but it can't be 3 times a prime. We already discovered that at the start, actually, right?
Yeah.
So if it's a multiple of a prime, that multiple has to be 2, yeah? Okay. So basically, n at the moment, we know n has to basically be 2 times a prime, yeah? Or a prime, I guess. Yeah. Can it be a prime? Like 5, yeah? 5 minus 3 was 2, yeah? So it could be 5, yeah?
5 minus 3 is 10.
Yeah. So what's another number that's like a prime or 2 times a prime? That's bigger than 10, maybe. So you get like 14. Yeah.
I'm gonna try 18.
Try 18. So 18 is probably not going to work, yeah? Because 18 is lots of 3s.
16?
16 is lots of 2s. Lots of, okay, maybe a power of 2 then, okay? So if this prime is not odd, it could be interesting. So what happens if it's like 16, yeah? So 16 minus 3 is 13, minus 5 is 11, minus 7 is 9, is not prime, yeah? Annie, 我送它下来。Alright, 5 more minutes. Play. Alright, Lucas, Aiden, or Blake? Where's Blake go? Tell us. Do you have any thoughts on this?
$14 won't work.
So 14 won't work?
Yeah. Because you can get 9.
Okay. Yeah. Yeah, so you know the odd primes won't work, right?
Yeah.
Because they'll give you even numbers. Yeah. So like odd prime won't work. So actually n has to be 2 times a prime. Unless it's like a really small odd prime, but then we don't really care about that because they're less than 10, yeah? Yeah, so a big odd prime minus 3 will be even, yeah?
Yeah.
So, for example, 7 minus 3. So 7's already not going to work for primes, yeah? So n literally has to be 2 times a prime. Okay? Huh?
I'll try 22. That might work.
22.
Yeah. Good work.
Okay, so 22, let's see. 22, we can try it very quickly. So 22 minus 3 is 19. Minus 5 is 17. Minus 7 is 15 is not prime, yeah?
And it won't work for 24 either, because instead of minusing 5, you can just instead of minusing 7 to get 15, minus 9 to get 15.
Minus 9 to get 15.
So
Okay. Yeah, we should try some more numbers though. So, what other things are 2 times a prime? I already tried 16. Wait, sorry, no, 26. So we tried 26.
26. Minus 11.
Yeah. So I think do we have it's 2 times an odd prime, or that it's a power of 2 or something, right? Or it could be like could be a power of 2 as well, I guess.
Yeah.
We haven't ruled that out.
It can't be like close to an odd number that's not prime.
Hmm.
Like otherwise it can just minus a specific, like it can minus like 3 or 5 or 7 or something just to get to that number. It's
Wait.
like there are a lot of small odd numbers.
Yeah.
Small odd numbers. Like within 10, the only one that's not the only odd number that's not a prime is 9. So
Okay, so these are the only cases left. So it's either 2 times an odd prime, or it's a power of 2. Yeah.
32 is a power of 2.
Yeah. So far, the biggest one we found is 10, right? And we ruled out, so we ruled out 14. 14, yeah, we have ruled out 14,
Yeah.
22, 26,
16,
and
16,
34, say.
36 might work because it's 2.
Oh, no, 32 you mean. 36 is not hard to.
Oh yeah, 32. I'll try
Oh.
32 first.
So 32 minus 5 is 27, yeah, it's not prime. And then 34 minus 7 is 27.
Right. It can't be close to a number that's not prime. I mean, it can't be close to an odd number that's not.
Yeah. Yeah, that's a good idea. So I guess that's a good idea. So because 3, 5, 3, 5, and 7 are all prime, yeah?
Yeah.
Okay, and we're considering sort of bigger values of this, yeah?
Yeah.
Then 2p minus 3 2p minus 5 and 2p minus 7 have to basically be like almost like consecutive primes, yeah? Which is not easy to do actually, yeah? Can you explain why these can't all be prime?
Because
Alright, we're almost done guys, we're just a few more minutes, okay? Can you explain why they're all not always prime?
because prime number times 2 is not a prime number. And minus a specific amount that minus is 2 that's odd. That's odd, that's not divisible. I mean not prime.
Yeah, so the prime numbers have to be odd, right?
Yeah.
So it has to be like 1, it has to end in a 1, 3, but it can't end in a 5, right?
Yeah.
Unless it is 5, because then it'd be divisible by 5, so it can end in a 7 or a 9, right?
Yeah.
Yeah. But so if this is the lowest one here, right? Yeah. If that one ends in a 1, right? Can you see this one has to end in a 3? Yeah. And then this one has to end in a 5, which is not allowed, right?
Yeah.
Okay. So then that one can't end in a 1. It can't even end in a 3, right? So it has to end in a 7 or 9, yeah?
Yeah.
If this ends in a 7, then this one ends in a 9, right?
Yeah.
And then this one ends in a 1. Wait, end in a 1, right? Yeah? That makes sense. If this one ends in a 9, then this one ends in a 1, and this one ends in a 3. Is that right?
Yeah.
And we also have 2p minus 11, yeah?
Yeah.
If we need it. That skips one, yeah? So that means if 2p minus 7 is a 7, then that's a 9, that's a 1, and that skips to a 5. So it can't even be a 7, right? Oh, wait, sorry. If it's a 7, then this goes backwards to a 3. If this is a 9, then this is a 1 and this is a 3, yeah?
Yeah.
And this goes back to a 5, yeah? So so essentially, unless it's already pretty small, it can't be a 9, 1, or a 3, yeah?
Yeah.
So it has to be end in a 7, yeah?
Yeah.
So if we assume that ends in a 7, this ends in a 9, this ends in a 1, and this ends in a 3, right?
Yeah.
Okay, let's see if we can go any further with this. So counting backwards. And then 2p minus 11. This idea is probably going to break the problem, yeah? It's just maybe not as nice as I would have liked. But okay, so then 2p minus 13 is a 3 again, right?
Yeah.
2p minus 17 is a 9.
Yeah.
2p minus 19 is, we're going backwards here, right? So is a 7, yeah?
Yeah.
Okay, unfortunately there's no 2p minus 21. 2p minus 23 is a 3 again, yeah?
Yeah. There's minus
Yeah, so it's actually pretty clear what we need to do, right? So we know that 2p minus 3 ends in a 1, right?
Yeah.
So we just need to subtract, so ideally, something to make it end in a 5, yeah?
Yeah.
So, we need to subtract a 6, and then, like, tens, you know what I mean? Like, subtract, a prime, which is, like 29, yeah? So 2p minus 29, yeah, for example. So if 2p minus 3 ends in a 1, okay, then is 2p minus 29 should end in a 5, right?
Yeah.
There's another 26 from that, so it should end in a 5, yeah? Does that make sense? And so if it ends in a 5 and it's prime, then it actually it's equal to 5. Yeah? Okay, so then that shows you P is 34. Okay. So this is not the full solution, but this tells you how to solve it in the case that n is 2p. Yeah? Because it makes it only a very few number of possibilities you have to check. Yeah? And so 2p is 34 is... Have we already checked 34? We already checked 34. It doesn't work, right? Yeah. And so for that not to work, then 2p can't be bigger than 29, right? Well, it has to be one of these other cases. You see what I'm saying? Okay, but all of them are, I think, are all smaller than 24. Yeah, 34. Okay, and then I think we still haven't quite eliminated the powers of 2, but maybe that's something you can think about at home, okay? Alright, good stuff. Any questions? No? Yeah. Okay, so the homework is to complete this argument for 2 times p, and also to see what happens with powers of 2. Okay? Alright, and then Tournament of Towns this Saturday. Alright, that's it. You can go home.
Thank you.
Alright, thanks, Aiden.
See you on Saturday.
Oh, what time can you come?
My game starts at 10.
Oh, okay. Well, just yeah, it's alright. I'll expect you probably around 12 or 1. Yeah.
Yeah.
Okay, but for other people, it's at 10. Yeah. Just have a little bit of a time handicap. Okay.
Alright, see ya.
Alright. See you.
Can I go to the toilet?
Maybe. I don't know. You could have tried harder.
Bye, Ernest.
Alright. See you, Ernest.